Okay, we're going to be doing lesson 2.7, and the lesson is dividing decimals. And we're going to start by dividing decimals by whole numbers. When you divide a decimal by a whole number, you notice here in your dividend you have a decimal point, and you just go straight up and you place the decimal point in the quotient. It says place the decimal point in the quotient above the decimal point in the dividend. Then divide as you would with whole numbers. Continue until there is no remainder. Placing your decimal point is very important. It's very important to get that done correctly. So let's do a couple of examples where we're dividing a decimal by a whole number. 7.6 is close to 8. So 8 divided by 4 would be 2. That's an estimate of your answer. Notice this is the dividend, it goes here. This is the divisor, it goes here. Alright, we've already placed our decimal point straight up above the other decimal point, and we just divide like normal. So we ask ourselves, how many times does 4 go into 7? One time. We subtract 4, we get 3, bring down the 6. 4 goes into 36 9 times. We subtract, we have 0, so no remainder. So the answer is 1 9/10. Is our answer reasonable? Yes, because 1 9/10 is very close to 2. We can do the same thing even if we're dividing by a 2-digit number. We have 4 374 thousandths divided by 12. Place our decimal point. Now 12 will not go into 4, so it's good to go ahead and place a 0 there because it won't go into it. But it will go into 43 3 times. 12 times 3 is 36. You subtract, you get 7. Bring down the other 7. 12 goes into 77 6 times. 12 times 6 is 72. We subtract, we get 5. Bring down the 4. 12 goes into 54 4 times. We subtract, we get 48. Subtract 48 from 54, we've got 6. So we cannot have a remainder when we're dividing. We get a decimal answer. In other words, we can't write the answer as 364 thousandths with a remainder of 6. You can't do that, and you can't write it as a fraction. So what we need to do is add another 0. We're going to add another 0 here and bring it down. Now, 12 will go into 60 an even number of times. It'll go 5 times. We subtract, we get 0. You can check your answer. If you multiply your quotient by your divisor, you should get the dividend. Remember, you can stop to look at the work at any time to see if you understand. Alright, that was dividing by a decimal by a whole number. What happens if you divide a decimal by a decimal? So dividing a decimal by a decimal, it's not something you can do leaving it like this. We're going to need our divisor to be a whole number, okay? So what we need to do is, back in the day we used to say move your decimal point 1 time over or 2 times over or however much, so this would be a whole number, but what you're actually doing is multiplying your divisor by 10 if you do one time to the right. But if you multiply your divisor by 10, you also have to multiply your dividend by 10, so your answer will stay in balance. So it says to multiply the divisor and the dividend by a power of 10, so 10, 100, 1000, to make the divisor a whole number. Then place the decimal point in the quotient above the decimal point in the dividend and divide as you would with whole numbers. Continue until there is no remainder, okay? So if I had something, well, there's probably an example of this, but if I needed to move my decimal point over more than one time, that would be multiplying by 100 if I moved it over twice, or 1000 if I moved it 3 times. So let's look at some examples of that. Alright, so we have 18 2/10 divided by 1 4/10. Let's set up our problem. Notice that this is a 1.4 or 1 4/10, so we need to make it a whole number. So to make 1 4/10 a whole number, we multiply it by 10, and that'll make the number 14. Notice we have to do it to both. And I like how they rewrote it over here. Sometimes people try to just like write their new decimal points, and sometimes that works and sometimes it doesn't. Go ahead and place your decimal point at the end because you might need it. And go ahead and place it up here because that way you know you'll have it. So for instance, you remember on the other problem we had to add a 0 at the end and keep dividing? If that happens here, you'll already have your decimal point in place. So here's the math. It goes an even number of times, so there's no remainder. And so you might think, well, I didn't need that decimal point, Miss Oldag, but there are times you probably are going to need that decimal point. So it makes a note here that if you multiply the divisor and the dividend by a power of 10, by the same power of 10, it does not change the quotient. So if you multiply this one by 10, you got to multiply this one by 10 as well. You give some examples here showing that your answer is 13 no matter how you do it, because you're increasing the power of each one by 10. All right, so suppose we have 273 thousandths divided by 39 hundredths, okay? So the divisor is going to tell us, this is the one that tells us what we're going to multiply by. Are we going to multiply it by 10, 100, or 1,000? So this is where we look to decide that. So obviously it needs to move over twice. So that means we're going to multiply by 100, a power of 10 and another power of 10. 10 times 10. Notice they rewrote it. This did not move the decimal point all the way to the end of this number. It's here between the 7 and the 3. Once you get your decimal point there, it's very important you move your decimal point up there for your quotient. So you ask yourself, how many times will 39 go into 27? It goes 0 times. Then you have to ask yourself, how many times will 39 go into 273? It goes 7 times. You might have to do some trial and error. And we get a remainder of 0. So our answer was 7/10. And we can check that by multiplying our quotient times our divisor, and we should get the dividend. All right, let's look at the next concept, or example 3. If you're in your book, this is on page 90. So we have 2 and 45 hundredths divided by 7 thousandths. So let's set up our problem. Notice here we need to move our decimal point over 3 times, which means we're multiplying by 1,000. Okay? So if we move this over twice, we might think, uh-oh, what do I do here? But we all know that there's an invisible 0 right there. Rewrite it. And now we have the same problem, actually, just no decimals. 2,450 divided by 7. I would go ahead and stick my decimal point right there, just in case. You're not finished. You gotta still bring down that 0. How many times does 7 go into 0? 0 times. This is where people get confused. They'll think, well, it doesn't go into 0, and they just stop. Well, if it doesn't go into it, that means it goes into it 0 times. Remember, you can check your answer. Does this times this equal this? It does. All right, next problem. 32 divided by 1 and 25 hundredths. Notice we're going to have to multiply by 100 times 10 times 10. Our decimal point is right here at the end, guys. Remember, every whole number has a decimal point, invisible decimal point, just sitting right there waiting for something. So we're going to move it over twice to the right, times 100. Think of it, 32 times 100 would be 3,200. Just think about that. You know that. So now we have 3,200 divided by 125. 125 goes into 320 2 times. I'm just going to go through the math here. We have a remainder. This is what I was telling you about. We can't leave it with a remainder because we're dividing with decimals. So what do we need to do? Well, I would have already put a decimal point here and went ahead and put it up here. They did not do that, but they're going to have to now. Then you can add the 0 and bring it down. Hopefully it'll go into that an even number of times. It does. It goes into it 6 times. You can check your answer and make sure that you're right. All right, modeling in real life. How many times more cell phone subscribers were there in 2015 than in 1990? Round to the nearest whole number. So we're going to divide the number of subscribers in 2015 by the number of subscribers in 1990. Because it's how many times more, not how many more, but how many times more. So that's why we're going to divide. Inverse operation. Okay, so we see that in 2015, go up here, there was 377 and 92 million subscribers in 2015 and 5 3/10 million in 1990. So how many times more is this than this? To figure out how many times more, we got to divide. They're going to show us on the chart how to read it. Now it'll tell us how many times more. We're going to move our decimal over once to the right, multiply them each by a power of 10. We're going to rewrite it. Go ahead and put our decimal point up in our quotient so we don't forget it. All right, 53 won't go into 37, but it goes into 377 7 times. Make sure you put it right above that second 7. This is where another place where people make errors. They put it in the wrong place. If you want to put an X here and an X here so you don't accidentally do that, put it in the wrong place, you're good. 371, subtract to get 69. How many times is 53 going to 69? 1 time. Notice it goes right over the 9. We subtract, we get 16, bring down the 2. How many times is 53 going to 162? 3 times. We have a remainder. What are we going to do? Well, let's see. They're just going to round it because it says how many times more cell phone, how many times more. And so they don't care. It says if we have an exact number, they want us to round it to the nearest whole number. We have enough information to do that now because we have 71 and 3/10. So 3/10 won't round up. It won't round this up to 72. Remember, it has to be 5 or more to round up. So our answer is going to be 71. There's about 71 times more subscribers in 2015 than in 1990. We check our reasonableness. I can't talk. They're showing us that this is a reasonable answer because this is between 370 and 380. So they're saying we could divide it by 5, we could divide it by 6, overestimate, underestimate. Our answer is going to be between 76 and 61. You might want to take time to just look at that and think about how they did that. All right. So this is the last assignment for the chapter. You need to make sure you do your homework and change the assignment just a little bit. It's 2.7 extra practice, page 78 on that packet I gave you. You need to do these problems, only these 10 problems. Number 2, number 4, number 8, 12, 16, 18, 22. Notice on 22 it says round to the nearest hundredth. And 24, 26, and 30. You do not have to do estimation unless you want to. If it'll help you make sure your answer is correct. Like I said, make sure you get that done. Take your test before you come back on that Tuesday, September the 7th, because I'm going to take up all your work then, and we're going to get right into Chapter 3, Ratios and Rates. So I will talk to you later. Thank you.